Welcome back from the break. Our next session title is Developing Culture to Write Reliable and Performant Services at Scale. Our speaker is Harshit. Go ahead, take it away.
Okay. Hi, everyone. So I hope everyone is doing well. Today, I will be speaking on developing culture to write reliable and performance services at scale, where I will be discussing about the observability, like how it plays a crucial role in your software development cycle, and how you can put that observability using like Python, where your services are built using Python based Python, and can establish. And also, I will be highlighting the kind of culture which you can establish within your team or the organization. So before starting with the talk, a bit introduction about myself. So currently I am a software engineer working at the Blinkit. In Blinkit is the India's e-commerce, which is delivering products in minutes. I'm from India, and I'm a tech speaker and have been part of multiple conferences in the past as a speaker. I'm an open source contributor, and also, like, in my free time I try to explore mostly the cloud native based open source organizations and try to contribute in that. Apart from that, I've been like past Google Summer of Code student also during my undergraduate studies. Yeah. So let's begin with first, like, why do we write software? We write software to basically solve problems, right? Uh, by solving problems, we are kind of making life easier for the people. So the software is helping making life easier for the people. There are like two kinds of software. Like if we can highlight it, one is like the good software, where and the another is bad software. Good software is kind of implies like you have a good amount of users traffic coming and you have a good engagement on your platform, which can directly impact your business profits in terms of revenue. Bad software implies like your code is actually not working as expected, and there are several, like, certain some downtimes, and which is causing business loss in terms of revenue. Considering if your software is a good software, you can expect such systems to have like these softwares can expect kind of a monthly active users linearly increasing. Like, see, users are using your software and they are enjoying it, they will recommend to others, then this traffic will keep on increasing. This kind of high throughput must be handled smoothly to make sure like people are enjoying and also you are making profits in your business. But turns out, like, sometimes things don't go well as expected, because here system reliability is important, where high number of user expectations should be met without any frustrations which can cause loss to the business. uh, like, in case of bad software, where like production issues happen and there are downtimes are kind of too like severe, and engineers try to understand the problem to resolve it. Like, they try to understand the problem within their internal systems, and if like they don't follow a best practice, it's like basically it's too late for them to understand like what's the root cause of it, and it's become hard for them to figure out what's going on, and the problem is already happening in production systems. So to bridge this kind of gap by making complex systems more transparent, we can set up monitoring of our systems based on the observability driven development. So as we can see, like, monitoring is not the same thing as observability. Like, they are very much similar terms, but they are kind of different. Like, uh, if I highlight, like, if as per the Google SRE book, monitoring systems must answer only two simple questions, like what's broken and why. uh, so monitoring is kind of a crucial thing. Like, it involves building dashboards, setting alerts. It lets you know about how's your microservices performing, and in the long term, it helps you understand the traffic growth, the trends, and how service is utilizing the machine resources on which it is running. Now, the comes the part where ecosystem where there are multiple systems are running. So this kind of system is like the distributed systems. So distributed systems, here the monitoring becomes a bit challenge and requires a deep dive into the internal states of each system as per their external outputs. This is where like kind of observability kicks in, and it provides an additional aid to your monitoring. Consider like observability is kind of like your code fitness tracker, where like you are counting every heartbeat and the healthy usage activity, making sure that your software stays in top shape like a marathon runner. If there is like no observability, there is no monitoring. So before deep diving into observability, like it's important to know these terms. What are the pillars of the observability? Because these will actually help you to avoid anti patterns in your software, and like they will be able to help you what kind of strategies were missed during your development phase. Because if you don't follow these like kinds of practice, it reflects like the inability to meet the promised SLAs or difficulty in tracking the business metrics, and considering the poor performance as a trade-off. So uh, these are kind of very much important pillars for the observability. So the three pillars are like the logging, metrics, and the trace events. I will be discussing these one by one first, before going into the culture building thing. And like I will be highlighting this with using small snippets using Python code. So looking at first the logging, let's discuss about the logging. So logging helps in understanding the behavior of this service during the runtime. Uh, like these are the recorded pieces of the information flowing through the service, and they are kind of typically saved in JSON format, where the developers can use some kind of patterns to match and see how their service is performing depending on the use case, like how they are using their logs. There are like kind of four logs, level logs, as you can see. Like there is debug, info, warning, and error. So debugging stands for like if you are doing some kind of debugging things, and mostly these types of logs are used at the in the like in local development. Then the second one is the information, which is kind of used for the general purpose logging. Then comes the warning logs, which actually is used to tell like hey, this is like not critical that much, but can be troublesome like in near future. And the fourth one is the error log, which is like mostly used to signify the errors in the application. The best practice to organize your logs for a Python based application is to have like first the module name, to identify quickly from which module the error got reported. Then comes the timestamp, which will tell you about at what timestamp the log was reported. And then comes the process ID. Process ID is kind of optional. It depends whether you want to add or not. It is kind of helpful when there are your systems are running multiple processes, and on the basis of that you can easily like you can tell which process ID logged this thing, etc. Then comes the log level. Log level basically again it tells about whether it's info, warning, error, and at the last the message basically tells you about like detail about what's happening in your like in the system. So here's a small example where I have set up a logger. So you can see there's a configure logger. I have set a level of info. That means uh, there, as I represented in my previous slide. So the order of logs is like debug, info, warning, and level. If so, here I have started my set level from the info level. So it means that my during when I will be running my system like in production, it won't be logging those logs which are at debug level. Those are mostly for the local development purpose, and they won't be getting stored on the production system. So it will be logging from info to warning and then error. uh, so you can see like at the right side in the top level, you can see that's a standard format of the log which comes. However, the best practice is to follow the JSON structured logs, which can be helpful in plotting the monitoring panels in form of graphs to understand the trend of your log, like the system or the API calls. Logs, again, as I mentioned earlier, like developers can use these logs to match on some kind of pattern, and they can uh, aggregate the logs data on the basis of some time intervals. Uh, that is, I think, I would say, kind of sample their data, and then they can create their own monitoring panels. A good example of monitoring panel can be like, let's say you have an API which kind of logs status codes, 5xx, 4xx, or 2xx. You can plot this trend by using the status code of the API which you are logging after request has been performed, and you can like understand the behavior of API, how many 4xx, 2xx you are getting. So this is another concept, like let's say you have a distributed environment. When distributed systems, there can be scenario like multiple instances are running, your system is handling a lot of requests from the users at scale. Now imagine you get an issue raised that one of the users is getting affected using your software. You want to debug the root cause of it. Directly looking into the request will be like very difficult to understand, because imagine like you are getting millions of requests and you are checking just for one user, or the one, like quite a set of users you are checking, they are being affected. So kind of to make sure you are looking into the right request, we use the concept of the trace ID. Trace IDs are actually helpful to track specific requests from start till the end, reflecting like how your system processed that particular request which was received by the system till the acknowledge which was sent to the client side. At request level, trace ID is like always unique. You can just simply look over the trace ID for the user and fetch logs, and it will be very simple to understand like what's affecting the user. Here at the like this is a small piece of code where I'm trying to simulate the two requests, and with different trace IDs. At the right side, you can see the request one is actually kind of a one session where the trace ID is unique for that particular session. Then the second request was like another kind of request and another session where the trace ID is unique for that case also. So here, by adding trace ID, it actually reduces the mean time to resolve a production issue. This is like kind of another best practice which you can use to kind of reduce the time to debug production issues. But there are certain limitations of the logging, like extensive logging can generate large volumes of data, leading to storage challenges. And these storage challenges can gradually increase the cost of running the infra, which is not a good thing. Uh, Careless logging practice can lead to sensitive information leaks, and which can raise some security concerns, which is again not a good idea. Log noise is another thing. Like if you don't follow, or within your team you don't kind of establish some standards, like your logs should be of this kind of format, and they can be a random format. They can be sometimes a bit noisy with access information, which is sometimes not helpful when you are debugging a production issue. Also, logging does not provide a quantitative measurement of the system behavior, like which quantitative measurements are like the CPU or the memory or system requires, and these things can actually help in the resource planning for running your systems at optimal infra cost. So this is where like metrics comes to the rescue. Metrics are kind of the quantitative measurement of the systems to understand how system is performing. It provides numerical and statistical insights, making it easier to track performance, detect anomalies, and measure trends. It also kind of helps in resource planning, as I mentioned like in my previous slide, where you can give you a better picture of how your CPU is, like system on which your like instance where how much CPU is being used, how much is CPU it is consuming, how much is the memory, and a lots of things others, etc. So apart from these, there are some 4 golden signals which are very much important for your software, which I think I should cover. One is like the latency, which defines about like how system is performing at the granular level and how much requests are taking to get processed by the server. Then the traffic throughput basically defines like how much request your systems is receiving like per minute or the per second. uh, then comes the error rate, which defines about the again the 5xx errors in your application, and that can be due to any recent deployment or can be malfunctioning of the external service or the database on which your service is actually dependent. The last it comes the saturation thing. Saturation is the main thing which tells you about the quantitative measurement, CPU, memory, disk IOPS, etc. So let's look into one of the examples. So here is like one of the example which I've actually picked from the official documents of the New Relic. So New Relic is kind of a third-party tool which is used for plotting the metrics for your services. It's a kind of APM-based third-party tool. Here you can see like it gives a proper summary of your service throughput, error rates, and how much your kind of overall like service APIs are taking time, transaction time actually. So this is the like the overview how it looks. Golden signals basically. Uh, there can be like more granular, like your metrics can be improved in a more granular way. Here, let's say here's one like a very small example of to make sure how things working. So like as I mentioned, so the New Relic thing, you can not only just see the throughput, error rate, or the transactions, but you can also see segments. Let's say you have one API, you want to have metrics at some pieces of code from which your API is dependent on. Let's say this is one of the code flow. There here is like this is the conference hall manager where I'm checking there's like 2 methods like book and the occupied. Book is actually telling like your conference hall is available for booking or not, or the conference hall is actually occupied or not. So considering this is working at a million of like traffic throughput is in millions, let's say. So things kind of get very difficult to understand like how much this piece of code might be taking. This is where like I can use these function traces, and I can get the average transaction calls and how much time it is taking. This is like just for understanding purpose example, but if your service is having a business layer and you want to actually look into like how much your algorithm is doing this piece of work, how much time it is taking, how much memory it is being utilized for x calls per minute, then these kind of function traces are really helpful. Another example is like using statsd, where statsd is another tool which in Python which I can use. Let's say I want some function to have let's say I want to have like to report a latency of a function running, and then I want to see, so you can use the latency calculation like the statsd timer can be used to measure the latency of a particular piece of function which is being run in your code. And apart from that, let's say there's an instance which is like in your business, like there's a logic in your business layer where it is dependent on it kinds of emitting some kind of messages or the events to a queue. Let's say this queue is your SQS queue. So you want to know like how much are the successful in queues and how many are the failed in queues. You can easily uh, emit that kind of data using the stats decline, and you can just plot it on your whether like plot it, and you can visualize your complete data how things are working, and you can understand if there's something gone wrong. Then you can like do some like can outline some actionables on it. So this was like about the metrics. Limitations are like there are some few kinds of limitations with the metrics as well. So they kind of provide very limited context, and they don't provide very rich context. Metrics mostly focus on the numerical values, and they provide insights into like trends. They kind of, what they are lacking actually is the information necessary to fully understand like the reason behind these certain values, why this is happening, why latency is so much, why my messages didn't got enqueued, why it got failed. These kinds of things which metrics don't answer. Sometimes like another thing is like the metric overload thing, where sometimes like tracking too many metrics can lead to some information overload, making it difficult to focus on what's important. And over optimization is like only solely dependent on the metrics decision making can lead to over optimization. This is where events come in the picture. So events are kind of the fundamental component of the observability, but they slightly provide a different purpose compared to logs. They kind of provide a rich information. Like they will actually tell you why the latency was increased, and why the basically the messages which were getting enqueued were, why they are getting failed, and so on. So they kind of include metadata and structured data like timestamps, event types, additional attributes, etc. So these events are actually helpful when you want to track even more granular level of business related events, like how many users are able to view the products, how many products are getting added to the cart, for example, like in case of e-commerce application, etc. These events can be used for the analytical purpose to make decision making and drive business, and it will help you understand like what is actually impacting the business, and how you can improve it. These events can be pushed like in columnar databases where you can, which are actually used for the analytical purposes, and you can understand the internal states of the application by querying on the large events data set. Some of the examples of the columnar databases are like Apache Cassandra and Amazon Redshift. So one of the example of the events is like this, where I will be like this is a kind of a schema for like booking events for the PyCon conference, and it has this user ID, event type, action. Action will tell you about the order placed, order cancelled. Then there's ticket type, student, professional, hobbyist, whether. So kind of this is again like a small piece of code where I'm using a traditional RDS just for sake of example. However, like when you're working on the scale, I would recommend like columnar databases are like much better for this use case. Then comes like here at the right bottom, you can see the ticket booking event I am creating, where I'm passing the request context. Request context will be having the user ID and the other metadata which is required for the reporting the events. And in the set event attributes, I'm kind of actually setting like what was the action where the order was placed or the cancelled, or what was a ticket type, was it student, professional, or hobbyist. And at the end, like I'm using the emit method, which is kind of emitting my complete data into the RDS. So this is like the overall example of the events. Now we have covered like almost all the three pillars of the observability. Now let's take a look into how to build and drive that culture within your team. uh, First thing comes like education. Like educating the team is very much important for like very much important. You have to teach your team the importance of the observability and how it contributes to building reliable and maintainable systems. Set clear goals within your team for the observability with, and like discuss on things like what aspects of your system do you want to monitor, and what key metrics are the business critical to make sure your service is up and running and doing like solving business problems as expected. Use of second thing is like using right tools and standardize the events format. Like use of observability, right, like right tools for the observability is important. It can be a good investment that which can help you capture events, logs, metrics effectively. These I've already discussed in my few like previous slides. Choose tools that kind of support visualization data, alerting, and the analysis of observability data. These tools should be like encouraged, and so that developers can maintain their code and also instrument their code as well. Events should follow a standardized format. This consistency aids in later analysis and troubleshooting during production issues very much easily. Add automated alerts on the basis of their thresholds. Like once you have monitoring panels ready, you can add automated alerts to detect anomalies in your metrics, or make sure, because like to make sure like there's nothing production impacting as such. Those alerts should be also relevant for the team as well. Uh, this is another important thing: post incident reviews. Conducting post incident reviews is a good practice. Every production incident should have a report known as the RCA, which stands for root cause analysis, which tells about production issue, how system working, which component of the system failed, how it got fixed, and outlining the action items to prevent the issue in the future. Overall, RCA helps in understanding the root causes and helps in identifying the areas for the improvement. Uh, at the last, also lead by the example and celebrate success. As a leader of the team, you should demonstrate the observability practices in your own work. Show the value of observability through the real life examples and some success stories, sharing tech blogs, or share some learnings which you have recently solved. Uh, Create some documentations and resources, outline some observability practices, tools, and their usage. Make it easy for like team members to access those docs and refer them whenever required. At last, like, don't forget to celebrate success, because you are doing a much of the hard work, and celebrate where observability driven practice have actually led to the quicker production issue resolution or enhanced the system performance. uh, that's it. I would like to like end this with a note, like remember that building an observability driven culture takes time and commitment, and it requires an ongoing effort and the continuous improvement. Thank you so much.
Thank you for your time. We have space for exactly one question before we have to take our break. If someone wants to raise their hands. Can't see any questions in the audience currently. Thank you so much. Can we get another round of applause?